So in this video I am going to show you how we can get spectral signatures from different locations of Earth and plot it in a graph. So those who are not familiar with what is a spectral signature, in the simplest sense, a spectral signature is the variation of reflectance of a surface with respect to wavelengths. So when you are working with remote sensing datasets, when especially working with land cover and use classification maps and other types of analysis, this spectral signature is really valuable when classifying a map to a certain classes. So in the next lectures we will be covering this in a very detailed manner when we are discussing about supervised classifications. So don't worry if you are not familiar with the concept of spectral signatures right now, because we will discuss these concepts in upcoming lectures. So I have already wrote my code in here in order to save the time. So we have defined three major classes here for water, forest and urban. So in here you can see I have defined the geometry as a rectangle, and here the upper right corner and this is lower left corner of the area. So I have chosen these coordinates from a location in Sri Lanka in Kataragama area. So for water features I have used this Lunugam Reservoir area as a inland water spectral signature, and then I obtained the Kataragama area, which is an urban area in Sri Lanka, and obtained the spectral signature for there. And also in here the Yala National Park as well as the Lunugam National Park, I obtained the forest cover sample in order to classify forest cover. So likewise we can define rectangle feature collections, and then later we can get this into the we can create a time series graph from that. So before I do that, we need to obtain, or we should import a Landsat image, because we are using this region of interest and obtain the spectral variation of this Landsat image. For this example I have used Landsat 8 band number 5, which is near infrared, and as we did plenty of times I have used this collection ID in order to select the band 5, and I filtered the dates, only the dates and all the images from 2014. So in here I have included the signature TOA, which is the image filtering parameters, and I also got the Sri Lanka region of interest sample areas, and I used the reducer factor as mean. So when we are calculating the ROI spectral signatures, it will consider the mean value of that reflectance with respect to the water, forest and urban. And then I have used the scale as 200, and finally I have given a title for that spectral signature graph. So finally we can give the color codes for each and every spectral signatures, because it would be easier to identify when we are looking at the spectral graph. So in here I have used red color for the urban environment, and forest cover will be denoted in the green color, and finally blue color is used to represent the water. So we can run the program and see how it works. So we can open it. So when you look at the graph, you can see there is an interesting pattern appears. So in blue color it represents the urban environment, which has a high reflectance compared to the other uh, categories. So which means that it responds to band 5 and have a high reflectance value comparing to the other categories. So see you in the next video.